guys, so good evening and welcome back to my magical world. It's me, Frostbite Goddess, your favorite celebrity here in the Philippines. It's 22:37:38 in the evening right now. Um, ano ba? Sinabi ko na yung date. Wait lang. Pagod ako guys. I went outside. O basta, Sunday ngayon, August 17, okay? I'm gonna read 275 of the book Mastery. Kaya ready na ba kayo? So, continue na. So, in the late 19th century, however, certain cracks began to emerge in Newton's concept of the mechanical universe. Based on the work of Michael Faraday, the great Scottish mathematician James Maxwell made some interesting discoveries about the properties of electromagnetism, developing what became known as field theories. Maxwell asserted that electromagnetism should not be described in terms of charged particles, but rather in terms of fields in space that have the continual potential to be converted into electromagnetism. This field consists of vectors of stress that can be charged at any point. By his calculations, electromagnetism waves move at the speed of 186,000 miles per second, which happens to be the speed of light. This could not simply by some coincidence. Light must therefore be a visible manifestation of an entire spectrum of electromagnetic waves. This was a groundbreaking and novel concept of the physical universe. But to make it consistent with Newton, Maxwell and others assumed that existence of a light-bearing ether, a substance that could oscillate and produce the electromagnetic waves analogous to water for ocean waves or air for sound waves. This concept added one more absolute to Newtonian equation, that of absolute rest. The speed of the movement of these waves could only be measured against the backdrop of something at rest, which would be the ether itself. This ether would have to be something strange, covering the entire universe, but not in any way interfering with the movement of planets or objects. Scientists around the world had been struggling for decades to prove somehow the existence of this ether, concocting all sorts of elaborate experiments, but it seemed an impossible quest. And this raised increasingly more questions about a Newtonian universe and the absolutes on which it depended. Albert Einstein devoured everything he could about Maxwell's work and raised questions it raised. Einstein himself had a basic need to believe in laws and the existence of an ordered universe, and experiencing doubts on these laws caused him great anxiety. One day, in the midst of all these thoughts, and while still while still attending the school of Arau, an image appeared in his mind, that of a man moving at the speed of light itself. As he pondered this image, it turned into a sort of puzzle, or what he would later call a thought experiment. If the man were moving at the speed of light alongside a light beam, he should be able to observe such a beam of light as an electromagnetic field at rest, though spatially oscillating. Intuitively, however, this made no sense to him for two reasons. The moment the man would look at the light source to see the beam, the light pulse would be moving ahead of him at the speed of light. He could not perceive it otherwise, since visible light travels at the constant speed. The speed of the light pulse with respect to the observer would still be 186,000 miles per second. The law governing the speed of light or any electromagnetic wave would have to be the same to someone standing still on Earth or someone theoretically moving at the speed of light. So, ayun na guys. Okay na yun. Later we'll continue. Thank you guys for listening. Thank you for helping me make this world a better place for all of us and for the future generations.